In this video, we will look at a few examples to practice working with mutually exclusive events. In example A, it says, what is the probability of randomly picking a number from 1 to 10 that is even, or randomly picking a number from 1 to 10 that is odd? So the first thing you want to think about is, are these two events, and the events are picking a number from 1 to 10 that is even, that's event A, and picking a number from 1 to 10 that is odd, that would be event B. Are those two events mutually exclusive? So you want to think about, is it possible to both pick an even number and an odd number at the same time? And the answer is no, it's not. The number you pick will either be even or odd. Those two events share no overlap, so they are mutually exclusive. So what we can do is figure out the probability of each event and then add them up. So the probability that we pick an even number when we pick a number from 1 to 10 will be 5 out of 10. That's because there are 5 even numbers between 1 and 10. Our sample space is all the numbers from 1 to 10. So the even numbers would be 2, 4, 6, 8, and 10. And there are 5 of those out of the 10 total numbers from 1 to 10. Similarly, the probability of choosing an odd number is also 5 out of 10 because there are 5 odd numbers between 1 and 10. Therefore, the probability of choosing either an even number or an odd number, which is what the question was asking, would be 5 out of 10 plus 5 out of 10, which is just 1. When you think about it, it should make sense, because if you choose a number from 1 to 10, it will either be even or odd, and there's no other options. So the probability that you choose an even or an odd number is 1, which is like 100%. Let's now look at example B. 2 fair dice are rolled. What is the probability of getting a sum less than 7 or a sum equal to 10? All right, so first of all, once again, these two events are mutually exclusive, because if you roll 2 fair dice, the sum will either be less than 7 or greater than 7 and possibly equal to 10. But you could never have a sum that's both less than 7 and equal to 10 at the same time. So the two events are mutually exclusive. And to solve this problem, what we're going to do is figure out the probability of each of these events and add them up. Now, when you're dealing with dice problems, like when you roll 2 dice and you're thinking about the sum, a great way to start is to organize all the possible sums that you could get by making a little table. So what you want to do this, and this is a really common trick that will help you out, is start by making a table and label 1 through 6 for your columns and 1 through 6 for your rows, because those are the possible numbers that you can get when you roll a die. Now that you've set up your table, in each box you're going to put the sum of the numbers from the corresponding row and column. So for example, in the upper left box, you'll put a 2 because 1 plus 1 is 2. And then here you'll put 3, 4, 5, 6, 7, and so on. And what you're doing is keeping track of all the possible sums that you can get when you roll 2 dice. And that's what it looks like when it's done. So now we can see that there are 36 boxes here. So our sample space is 36 pieces big. So now we want to think about our probabilities. Our first event was getting a sum less than 7. So we can look in our table to look for all of the possible sums that are less than 7. And let's highlight those. So that would be all of these right here, everything above those line of 7s. So the probability of getting a sum less than 7 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 36. So you just count up how many boxes we highlighted and put that out of 36, which is the total number of boxes. So the probability here is 15 out of 36. Now the other event was a sum equal to 10. And we can see that we have 3 of those possible outcomes. So the probability of getting a sum equal to 10 would be 3 out of 36. And because these two events are mutually exclusive, they don't overlap at all. We can see that from the highlighting. There's no box that was highlighted twice. We can just add up the probabilities, and we get 15 out of 36 plus 3 out of 36, which is 18 out of 36, which reduces to 1/2.